Alright, so for this video, we're going to be discussing how to identify different number types. We'll start with the most basic and work our way up. So the most basic, we have the natural numbers, or the counting numbers. Numbers like 1, 2, 3, 4, 5, all the way up to positive infinity. So these numbers are considered the most basic and the least inclusive of all the number types. Moving up from natural numbers, we move to whole numbers. Whole numbers include all natural numbers. However, they have an addition of 0. So all whole numbers include 0, 1, 2, 3, all the way up to infinity. Moving on from there, we have integers. All whole numbers are integers. But integers also include negative whole numbers, like -4, -50, -100. So all integers can include stuff like -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Moving up from there, we have the rational numbers. Rational numbers are any number that you can make a fraction from. So for example, for -4, we could have the fraction -4 over 1. Because these are non-repeating decimals, this works as a fraction. Another example would be -2.5. For here, we have -5 over 2. Again, these are whole numbers, not decimals, so we can say that these are rational numbers. Juxtaposed to rational numbers are irrational numbers. These are numbers that when you make a fraction from them, you can't use a whole number. For example, -2 is approximately 1.4 on from there. So there's no way that we can reduce the square root of 2 to a fraction without it being a decimal on either the top or the bottom. So it would be an irrational number. A more classic example would be pi. Pi is 3.14159 going on from there with a repeating decimal. So we can't make a whole number fraction from pi. So it's also considered an irrational number. If you have any questions on that, I'll be happy to message you privately on Canvas. Overarching this, we have all the real numbers. The real numbers are all the numbers which can actually exist. They include both the rational numbers and the irrational numbers. We will not be discussing in this course complex numbers, which are numbers which kind of exist, but in the real world may not actually exist. For example, the square root of a negative number doesn't actually exist, which is why we use I to represent the square root of -1. But we won't be discussing complex numbers at this stage yet. So